Today we are working on 6b, which is the slope formula. Our content objective is students will be able to find the slope of a line given two ordered pairs, and our language objective is students will be able to state verbally the difference between having a slope of 0 and having a slope that's undefined. Why am I learning this? Well, it's important for solving real-world problems, such as finding out how quickly the amount of water in a reservoir is changing. So first, like always, we're going to go over some background knowledge. In the past, we found the rate of change, aka slope, based from a table by finding the change in y over the change in x. So these were ratios. We checked them one by one, and we wanted to make sure they were constant. If so, then we can state at the end that we had a slope. In this case, the slope was negative 1/2. If we wanted to write an equation, we would have needed the y-intercept to determine that in this case, b equals -4. So now that I know what b is and I know what m is, I can use slope-intercept form, plug it into y equals mx plus b, and my equation, would be y equals -1/2 x minus 4. So hopefully that looks familiar. So now we're going to move on to some new material. So an algebraic method to finding slope given 2 points would be to first understand slope is your vertical change over horizontal change, which can also will be referred to as rise over run, the change in y over the change in x, etc. I've taught you a few definitions. They all mean the same thing. So in this case, it is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I know what some of you are thinking. That looks a little bit intimidating. However, if you connect it back to delta y over delta x, if you remember, delta means change or difference. In this case, if you use the word difference, it just means you're subtracting the y values and you're subtracting the x values in a particular order, of course. In this case, you do second minus first. So what am I talking about when I say second or minus first? Well, obviously, you need two ordered pairs in order to find the slope. You can call one the first one and the other one the second one. So in this case, this would be x sub 1, y sub 1, because this is the first x and this is the first y. And in this case, I can call it x sub 2, y sub 2, because this is the second x and this is your second y. So here's something that I do personally that I think might help you use this formula. I first start off with boxes for each value, and I put a subtraction sign in between since we are finding the difference. Why would I do this? Well, some of my students in the past, as they're using this formula, if the number was negative, they would often forget this subtraction sign. So to kind of keep things consistent and to make sure you don't lose any parts of your formula, I do write it like this. So what do I do with this formula? Well, I'm going to have to find the difference in y. And how will I do that? Well, essentially, you're trying to find out how did a -3 become a 2? And what do you do in order to get that? Well, you take y sub 2, which is in this case a 2, and you subtract y sub 1, which in this case is a -3. So here I'm going to add the opposite, and that's going to leave me with a 5. So now let's just check real quick. Was my vertical change a 5? 1, 2, 3, 4, 5. It was, and since it went up, it is positive. Okay. So now let's look at our horizontal change, so the difference in the x's. So what you're trying to do is figure out how did -2 become a 1? But how do I do that if I don't know, since negatives and positives are kind of tricky? Well, what you can do is take the second x, which in this case is 1, subtract the first x, which was -2. Here I'm going to add the opposite, so 1 plus 2 is 3. So at this point, I can check real quick, was my horizontal change a 3? It went over 1, 2, 3 to the right, so yes, it would be 3. So I would say my slope is 5/3. So hopefully with this formula, you're going to be able to determine the slope based off two ordered pairs. So let's practice it a little bit. Your first x, your first y. Here I'm going to call it x sub 2, y sub 2, and again, this basically means your second x and your second y. So now what I like to do is go ahead and put in boxes, and the reason why I do this is so that you don't accidentally lose your subtraction sign in between. Now all I need to do is plug in my values. First I'm going to find the difference in y's, and I always do the second y minus the first y. So the second y is a 9. So I'm going to go ahead and write that down. And the first y is a 5. So 9 minus 5 is 4. I'm just going to double check to see if this is true. Do I need to add 5 plus 4 to give me 9? The correct answer is yes. So far so good. Now I'm going to repeat the process. I'm going to find the difference in the x's. So I'm going to do x sub 2 minus x sub 1. So x sub 2 is 6. I'm going to put that in my box, minus x sub 1, which is 2. So here 6 minus 2 is 4. So I'm going to say 4 divided by 4 will simplify to 1. Now another method other than using the slope formula would be to also graph the points to find your vertical change over your horizontal change. So let's see that. Here I'm going to plot the 2 points on my graph. I'm going to draw my line. And then I'm going to look for my vertical change. So in this case, it's changing 4 up, so that's positive. Then it's changing 4 to the right, so that's also positive. So here, if I write things in the case of vertical change over horizontal change, I would have that slope is positive 4 over positive 4, which once again will reduce to 1. So here, notice that it doesn't matter which method you choose, whether it's using the slope formula or graphing it in a graph, you will still get the same slope. So now we're going to go ahead and jump into the next example here. The instructions are the same. We're going to find the slope using the slope formula given 2 points. Now, just like before, what you're going to want to do is write down your formula, the difference in y's over the difference in x. So again, second y minus the first y, second x minus the first x. So here what I want to do is label which one is my first x, which one is my first y, etc. So I'm going to go ahead and write that underneath so I know which one's which. Since this is my first ordered pair, that's x sub 1, y sub 1. Since this is the second ordered pair, I'm going to call this x sub 2, y sub 2. Now that I've established that, I'm going to go ahead and put in my boxes so that I can easily just put in my answers. Not answers, sorry, my values. So here, what is y sub 2? It is negative 5. I will be subtracting y sub 1, which is 7. So here, I'm going to add the opposite and say negative 5 plus negative 7 is negative 12. And then here, I'm going to find the difference in the x's. What is x sub 2? X sub 2 is 5. Minus what is x sub 1, which is negative 3. I'm going to go ahead and add the opposites, and I'm going to get 5 plus 3 is 8. Now, before I claim that I'm done, I'm going to have to check if I can reduce. In this case, I can. I'm going to divide both the numerator and denominator by 4. And the final answer is m equals negative 3 halves. So my slope is negative 3 halves, and I got that using the slope formula. But what if instead I wanted to use a graph? What would I do? I'm going to go ahead and plot the 2 points, draw my line, and determine what my vertical change is in comparison to my horizontal change. So here I'm just going to count that it's changing down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Since it's going down, that is a negative 12. Then from that point, I'm going to go to the right 1, 2, 3, 4, 5, 6, 7, 8. Since it went 8 to the right, that's going to be positive 8. So here, the vertical change was negative 12. The horizontal change was positive 8. So this would reduce to negative 3 halves. And again, I'm just reducing by 4. So once more, you're going to notice it doesn't matter which method you choose, you're still going to get the same answer. Okay, so now what I'm going to have you do is try the next problem on your own. So go ahead and pause the video and see how well you do. Okay, so now we're going to check our work, so go ahead and double check your work with mine. First things first, we're going to write down the formula, and then we're going to go ahead and label which one's x sub 1, y sub 1, x sub 2, y sub 2. We're going to go ahead and place in our boxes so that we don't accidentally lose our subtraction sign. So here, what is y sub 2? It is 4. What is y sub 1? It is 1. So 4 minus 1 is 3. Now what about our x's to find the horizontal change? Well, I'm going to do negative 3, which is the second x, minus the first x, which is 6. I'm going to add the opposite. Here, negative 3 plus negative 6 is negative 9. I'm going to go ahead and reduce by 3, and my final answer is negative 1/3. But once more, you're also going to try the other method, which is to graph the 2 points on a graph. Determine what your horizontal change is. So in this case, it's changing by going down 1, 2, 3. Since that's down, that's a negative 3. And then I'm going to find out my horizontal change. It's going over 1, 2, 3, 4, 5, 6, 7, 8, 9. Since it's going 9 to the right, that's a positive 9. So here I'm going to say my vertical change was negative 3. My horizontal change was 9. So I'm going to say that my final answer is negative 1/3. And once more, you're able to see that both methods will get you the same slope. So hopefully you got that one right. If not, you might want to go back and see how the other ones were done, or check to see where your mistake occurred. So now I'm going to go ahead and also have you try number 4 by yourself. So go ahead and pause the video and see how well you do. So let's go ahead and check our work. First things first, we're going to write down our formula, and then because of our formula, we're going to want to identify each one of these coordinates. So I'm going to label x sub 1, y sub 1, and x sub 2, y sub 2. Now that I have all of these points labeled, I'm going to go ahead and plug it into the formula. First, I'm going to do the second y, which is 8, minus the first y, which is negative 2. You're going to add the opposite, which is going to give you 10. Now you're going to do the horizontal change. So you're going to do second x, which is 6, minus the first x, which is 3. 6 minus 3 is 3. You're going to check to see if you can simplify this. In this case, you can't. So my slope is just 10/3. Now let's double check on our graph. You're graphing the 2 points. You're drawing your line. You're determining what the vertical change is. So in this case, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Since it went up, that's a positive 10. Then you're going to see your horizontal change. It's going to the right, 1, 2, 3. So that is a positive 3. So notice your vertical change is 10. Your horizontal change is 3. So that is my slope since I can't reduce. And there you have it. So now let's talk about something here. Why in the world don't we use a graph every single time to find slope? So in other words, why don't we always just check vertical change over horizontal change? It seems like it's a little bit easier than the formula because I can visually see what the vertical change is and what the horizontal change is. Well, why wouldn't you want to? Because what if you're given an example like this, where the numbers are larger and it might not fit on your graph? Well, what are you going to do? So this is a prime example where using the formula can be very beneficial. In fact, what are some other scenarios where the slope formula would be useful? What if these points were decimals? What if these points were fractions? Those are great examples of when you would definitely want to use your slope formula, because on a graph you can't accurately say what the vertical change is or what the horizontal change is. So with these large numbers, let's go ahead and use the formula. We're going to write it down as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We're going to label which is which. So notice here I labeled it slightly different. I called it the first x, first y, second x, second y. Because I want you to understand that that's what it is. Okay? Here, now that I have my boxes, I'm going to go ahead and plug in the second y, which is 81, the first y, which is 76, and find the difference between those, which is 5, and do the same thing here. What is the second x? The second x is 45. What is the first x? The first x is 22. So 45 minus 22 is 23. So here I would say, since I can't reduce this fraction, that the slope is 5 over 23. Now, what about a graph? You're going to realize that you can't graph these points on such a small graph. Some of you might say, well, you can scale it. True, but if you're scaling it, how can you accurately tell me what the vertical change is and what the horizontal change is? It's not going to be as easy. So again, this is when your slope formula is useful. This is when you're going to definitely want to use your slope formula. Okay, so let's try another example. Go ahead and pause the video and see how you do with this example here. Okay, so here, first things first, we're going to use our formula. We're going to label each coordinate as first x, first y, second x, second y. We're going to go ahead and put our empty boxes so that we can easily substitute these values in. What is your second y? It's 43. What's your first y? It's 42, which is going to give me a difference of 1. Now, what about the x's? What's the second x? It's 22. What's your first x? Is negative 5. So here I'm going to add the opposites. 22 plus 5 is 27. And just a friendly reminder, the reason why I'm adding the opposite is because it's subtraction. So whenever there's subtraction problems, I do change them into addition problems by adding the opposite. But you'll notice here I didn't because I know how to do 43 minus 42. So back to the answer. This answer is already reduced, so I'm going to say the slope is 1 over 27. So once more, what about a graph? You're going to find that you won't be able to fit these points on the graph, so finding the vertical change over the horizontal change is not going to be helpful. Or in other words, finding the rise over run, it's not going to be that much help. So this is when using the slope formula is going to be beneficial to you. So let's go ahead and keep practicing using the formula. So in this example here, I'm going to go ahead and first write down the formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'm going to go ahead and label each of these coordinates. And I'm going to go ahead and plug it in. The second y is 2 minus the first y is 2, so 2 minus 2 is 0. Now here, what's x sub 2? X sub 2 is 1. X sub 1 is negative 2. So I'm going to add the opposite since it is subtraction. I'm going to add the opposite and I'm going to get 1 plus positive 2, which is 3. So here, 0 divided by 3. We want to say 0 divided by 3 is 0. But before we can state that, let's check our work to see if that's true or not. Does 0 times 3, does it really equal 0? The answer is yes, so I can confidently say that the slope is 0. Now let's try this one again. We're going to start with the formula. We're going to label each part, and then we're going to go ahead and plug it in. So y sub 2 minus y sub 1. I'm going to add the opposite, and I'm going to end up with negative 3 over. Now here I'm going to do x sub 2 minus x sub 1. I'm going to add the opposite. What's negative 3 plus positive 3? The answer is 0. So here we think negative 3 divided by 0 is 0, but let's check our work. Does 0 times 0, does it really equal negative 3? The answer is no. So here you can't say the slope is 0. You would have to say the slope is undefined. So notice the difference. The only way, not the only way, but the best way to check is by checking to see, does 0 times 3 really equal 0? If so, the slope is 0. Or in this case, does 0 times 0 really equal negative 3? No, so it would be undefined. So now if you look at graphing these things, if I graph these 2 points, you would see that it would make a horizontal line. So notice here, since it's a horizontal line, okay, it's not going up, nor is it going down as I read it from left to right. So that's why horizontal lines have a slope of 0, because there's no increase and there's no decrease. Now if you look at vertical lines, if you were to graph these 2 ordered pairs, you would find if I read it from left to right, we can't really see a trend. So here, that's why your slope is undefined. Okay, so let's connect it back to slopes that we've seen before. We always read slopes from left to right. So in this case, if you look at this, reading it from left to right, it's going up, therefore it's positive. Here, reading it from left to right, it's going down. That's why it's negative. And this slope here, since it's not going up or down, that's why my slope is 0. And here, you can't really see anything until you reach this point. So that's why there isn't a trend. So we would call it undefined. And that concludes our lesson for today. And like always, thank you so much for tuning in. And until next time, bye.